Hi everyone, and welcome to today's Physics Daily Booster. This is number 14 in our series for paper 1, and it is an advanced information listed topic on both foundation and higher physics. What we're going to do then is start off by understanding this term net resistance. When we refer to the net resistance, what we're actually saying is this is the resistance of a circuit if we took all of the components out and replace them with just a single resistor whose resistance was the same as all of them added together. Now, hopefully we understand the fact that our net resistance would change if we change the components or we change their arrangement, because obviously resistance does depend on what components are present and also how they're arranged within a circuit itself. What we need to know then is the impact, if you like, of adding additional components, and they quite like doing this one in terms of adding extra lamps in different places. Can be multiple choice, could be written answer. I've seen it as both over the years. If we add an identical lamp in a series circuit, the current is going to decrease, but the net resistance will increase. If, however, we add that identical lamp into a parallel circuit, the total current increases, whereas the net resistance will decrease. So just remember those patterns for series and parallel circuits, because as I say, they have given that as a question before, and I do remember relatively recently, I think it was a multiple choice question. What we are then going to come on to are potential calculations that we could be asked to do as far as different circuits are concerned. And in order to do this successfully, we need to remember some basic facts. First thing, for a series circuit, the current is the same everywhere. The potential differences across each component add up to the potential difference across the battery. And our old calculation, V equals IR, which, okay, you don't have to remember it, you just need to remember it's on the formula sheet this year. But series circuit, current is the same everywhere. PDs across each component add up to the PD across the battery. If we know those facts, we can then use V equals IR to calculate any scenario. If we're talking about a parallel circuit, then we need to remember these facts. The potential difference is the same across each loop. The current in each loop is going to add up to the current near the battery. And of course, V equals IR, which again, on the formula sheet, so less of remember the actual formula, more remember it exists and use it here. Let's take a moment just to have a look at one example of the kind of questions we could do with those facts. So here's one example. The potential difference of the battery is 12 volts, R1 is 10 ohms and R2 is 30 ohms. Calculate V out. And we've got a little diagram here showing us what we've got. Now, the first thing that we actually need to do here is calculate the net resistance. So our net resistance then, and I do apologise for my dodgy writing with a mouse, is just going to be resistor 1 plus resistor 2. So in this case, we have 10 and we've got 30. So resistor 1, 10 ohms, resistor 2, 30 ohms. So in total, that gives us 40 ohms as our net resistance. Okay. Once we've got our net resistance, we can then use V equals IR to calculate the current, because we're talking about a series circuit. And remember our rule there that the current is the same everywhere in a series circuit. So remember, on our formula sheet, we will get V equals IR. Now, what we're trying to do here is calculate current, so we need to rearrange it. So if we want to know current, it's just going to be V divided by R. Substitute it in, so our potential difference is 12, it tells us in the question there. So 12 divided by our resistance, which is 40 for our net resistance, and that gives us our value of 0.3 amps. So there's our current. Last thing to do then is calculate V out, which is the potential difference across resistor 2. So to calculate our potential difference, V equals IR, remember, so that's from our formula sheet. Now we know the current because the current is the same everywhere in a series circuit, so that's just going to be 0.3, and then we're going to multiply that by the resistance, which for resistor 2 is 30. So 0.3 times 30 gives us a total of 9.0, and that is volts. Job done. What we then find is that we could be asked about where we would use certain sensors. So they could ask you to give an example of where we would use a particular type of resistor. Now, light dependent resistors, remember LDR, that's all about something that's going to change with light levels. So it might be something like a security light, for example, that's going to come on as the light levels actually drop. We could use a variable resistor to monitor the positions of a door because it will monitor the resistance as the door moves, so it's turning, therefore it's going to be changing the resistance. We could use a pressure sensor in things like burglar alarms, so that when someone steps on a particular pressure plate, it will then sound that alarm. Last thing we're going to look at today is another calculation. So again, we are going to use our formula sheet here. Now, the calculation we're looking at is power. When we're talking about power, it is the rate of transfer of energy. The definition has been asked before as a question. Units are watts, however, watch out for these variations on watts in the unit. Kilowatts, that's just 1000 watts, and a megawatt, which is a capital M there, that is 1,000,000 watts. So just watch out for if they've given you an answer in kilowatts or in megawatts, convert to watts before you use it in any form of calculation. Otherwise, you're not going to get the marks. So you tend to see the megawatts where we're talking power stations, etc. Kilowatts, they can use for a range of different appliances. So just remember to check the units before you jump straight into the calculation. In terms of the formulas we could use, you'll notice at the bottom there are 3. That's because power is involved in 3 different formulas. Now, you might be sitting there thinking, well, how on earth am I to know which one to use if they're asking me to calculate power? And the answer is, look at what they've told you. Because if we have a look at these in turn, power is potential difference times current, energy transferred is power times time, or power is current squared times resistance. Now, each of them has different parts to the actual formula. So read the question, identify what bits they've given you, and then you'll be able to pick which one of these 3 is the right one to use. So quite simply, there's only going to be the one that fits with what they've given you, okay? So all you need to do, look carefully, identify what you've got in the question, look at your formula sheet and almost kind of tick them off very gently in pencil in order to identify which of the 3 formulas you can use. Just some basics, obviously, we have got a time in seconds there, make sure that they have given you the actual time in seconds, if not, convert. And of course, just double check that power in watts, that it's not in kilowatts or megawatts. If it is, convert before using it. And as always, show you're working in all stages and use a calculator to check your answer. Watch out for the question that's going to be somewhere on a paper asking you to give your answer to so many significant figures, because your answer to that number of significant figures is a mark on its own. So even if you look at that question and think, you know what, I don't have a clue how to work this out, even with my formula sheet, if you just write any old number to that number of significant figures, you get that significant figure mark, okay, because it's a separate criteria we're marking against for that one. It's the math skill we're marking for, not the actual answer. So don't leave it blank, write down a number to that number of significant figures. Hopefully you found this booster useful, and don't forget to join us again tomorrow for our next Physics Daily Booster. Obviously, if there are some bits that you want to go over in a bit more detail, have a little bit longer to look at, then use the video on the main channel, use your revision guides, look back in your classwork, just to really consolidate those facts. We are guaranteed to have calculations here, so it's almost worth just sitting there, getting the old exam papers on the OCR website and just flicking through, find the calculations on the paper ones, just do the lot of them. Because the more of them that you do, the better practiced you'll be, and the better you'll be when it comes to doing them in the real thing.